Hello, everyone. How are you all doing? I know it's been a long day, and so I wouldn't take much of your time. My name is Barnabas Nomo. I am a second-year student here at Academic City College, and I study computer engineering. And I started a project called AccraWAN in 2017 in order to build a cluster of low-powered wide area networks and collect data. And one of the key things that stand out for me is how to find ways to use the technology that surrounds a community to improve the livelihoods of the people there. And so the title of my talk, there are a lot of big words in there, but so it's a data-driven, two-dimensional public transport system in a three-dimensional home and work Accra. And so why Accra? So Accra is Ghana's capital, obviously. We have a population of about 2.5 million people. And there's a lot of abundant tech that has happened in the last couple of years. And so there have been so many companies that get enough investor funding to build. And most of these companies focus a lot on tech. And so there are people who are leveraging blockchain, AI to solve problems in healthcare and agriculture. And like everywhere, there's traffic. And so this is just a short experience that I had. While I was working on AccraWAN, I actually wanted an internship that will help me learn a lot about networking protocols. So I took an internship in a data center by the coast, and I stayed. I stayed up there in the blue, circle, somewhere around there. And this was the trip, right? It was supposed to take me about an hour each day. But then what ended up happening was, I looked this up on Google Maps, and I had planned my trip. I had gone to stay with my cousin. But I didn't know there was a place like this where literally all of the traffic in Ashaiman had to go through a very narrow tunnel. And so what ended up happening was that for the entire 2 months that I did my internship, I ended up spending about 5 hours every day, either inside or circumventing traffic. And just to save about 30 to 45 minutes so I could get to work early, I had to be 2 hours early. And sometimes I just had to sleep so that I lost track of the time passing where I was sitting down doing nothing. So I talked to a lot of my friends, and they also started telling me about how they have the same issues. And so I just want to define what I mean by dimensions, and then we can dive straight into it. And so when I talk about dimensions, as you can see here, our roads just have lanes, and there are so many cars packed one behind the other. And so if you model this as a matrix, it will be like a 2 by K matrix, where K is the number of cars, like each row. And so the other issue is that, we have our markets and our offices look something like this, where this was a picture taken in Makola very early before people started their day. And all the people in all these buildings were on the streets. And so you can see how much traffic that is just causing for people. But unlike people, you can't just use your car to step to the side of someone and cut in front of them. There are rules. And so one of the biggest initiatives that's running right now is Elon Musk's Boring, where they are digging tunnels under the ground to allow people to have a three-dimensional working environment, transport environment to meet their home and work environment. But luckily for Ghana, our home environments are not exactly three-dimensional yet. And so while we are waiting for things like this to happen, we could also govern all of these things if we had enough data to drive and inform our decisions. And also, Boring costs $10 million per mile. And in a place like Ghana, where you won't get a proper return on your investment, it will look as if you may die in traffic one day. And so the real hero of the story is in that picture there. And it's this guy, right? The Trotro. And the Trotro empowers the average Ghanaian, because for every Trotro on the road, that could have been 8 to 15 cars that were going to be parked on the road. Now, the thing about the Trotro is it's Ghana's primary public transport, especially in Accra. And there's this notable fact about Ghana that all the best things have to be said twice, like fufu, tro, cocoa, you know. And so, but the other issue is that in Ghana, all the churches are privately owned. And so there's a lot of chaos and confusion that happens. All these drivers have very small unions, but it's not something that's very solidified as an organization. And they are governed based on reaction, more or less, as in something happens, so let's do something about it. But there's no way to predict into the future and say, this is what we have to do. And a lot of the projects that happen in Ghana, when we build roads and all, we don't even know how many trotros are in Accra. And so how do we plan for the average Ghanaian to be able to get to work on time, get back early, so that they can have enough productive time to do things that matter to them? So I am a developer, and I like to build fun stuff. So I did this simple interface on my phone where each time I pass by a bus stop, I press log. And a little backstory, the first time I told someone about this, it was really stepped on because they felt like, you can't do this and there's too much chaos around and you can't really do anything about it. And so each time I pass by a bus stop, I'll hit a button. And then, I started to find out that not all bus stops are actually bus stops. And I'd explain that. So, okay, pop quiz. If you get this right, extra credits in your assessment. Who knows the name of that street, like the place where I've highlighted? You can look on the map if you think you know. So, as a guideline, this is in East Legon. There's a KFC right by here. And the blue circle. Who can guess? Oh, yeah. Yeah, so it's Lagos Avenue, but the people there call it Banku Junction. All right. And so if I ever told you, meet me at Banku Junction, and you entered it in Google Maps, you were going to end up in Morocco, actually. I tried this morning, so, all right. And so, yes, it's very unstructured, and there's a lot of chaos, right? But when I kept pushing a button at every bus stop, this is what I realized. That in the midst of all this chaos, what we have here is structured data, right? Like in the midst of all the chaos happening, we have structured data where you can tell the position of a bus at any point in time. You know its longitude, its latitude, and you know where it is heading and how fast it's going. That means you can do something about that. And so let's say if you run that through a neural network, you could have very interesting insights. For example, all our bus stops that are to the left of Medina will always go through 37, right? But what if there were other bus stops that these buses could take so that it optimized how people do their transportation in terms of if eight buses are going to use the same route and another route doesn't have a single person passing there in like an hour or 2 hours, then you can tell that there's an actual problem there. But people would say, if it's a problem, why don't the drivers realize? And so one time I was in a conversation with a trotro driver, and he told me, look, the odds of a driver being at the same place at the same time every day is extremely low because we have so many buses. And there are so many instances. Those of you who use trotro in this room will bear witness with me that sometimes, for example, at MaxMat, people would literally be at a bus stop waiting for a bus to Medina. And in order to catch a bus to Medina at 5 p.m., you need to be very good at wrestling because you have to push people out of the way. And meanwhile, there are cars still parked at the station waiting to be filled with people going to Medina. There are empty cars that pass by that don't know that there are people going to Medina here. And so I started to realize that if I decided to collect data on my own, it's going to be extremely problematic because, it's only one of me, and I can't hire enough people to do that. I'm not rich. And so this is what I mentioned earlier, that I was building a cluster of low-powered wide area networks. So this is a chipset that we started with. We are just iteratively designing the thing based on how people are using stuff. So it's a simple GPS tracker, the earliest version, and it talks to this box. So this is a LoRaWAN gateway. It's a low-powered wide area network. And so that on the left is, on your left, is just a simple pluggable microcontroller unit that you can put in these cars so you can track where they are at any point in time. And based on that, all of the data you collect, if you process them adequately, you can build plugins for mapping services like Mapbox, Google Maps, OpenStreetMaps, or SnooCode. And so the cool thing about LoRaWAN is when you have a gateway here, and actually the first LoRaWAN gateway, that ever came to Ghana is going to be hosted in the mast over there. Dr. Fred is still helping us with licensing and the proper channels. But any object within a 12-kilometer radius can communicate with this box if it has the right configuration set up. And so just to give you a cool idea of what a 12-kilometer radius looks like, one gateway basically covers all of Accra. So if you have 5, then you have the entire Accra covered up, and you still have redundancy so that if data fails, it can be handed over to other places. And so this was the initial idea, that we just build this and put them in cars and add buttons so that when someone joins, you push one. When someone drops, you push another one. But then we realized that the main key player is actually that guy over there, right? So I don't know him, he doesn't know me, but based on his job qualifications, so all these structures have what we call a mate, more like a conductor who takes the change and, handles all the operations in the bus so that the driver can drive peacefully. And right now, these are the things that the conductor does. So first of all, he's the cashier. He's also the bouncer. So if any arguments occur, he's the one taking care of that. He's also the public address system in terms of he shouts literally to say, hey guys, we are going in this direction of town. And, he announces the next stop, destination guide, passenger counter. And now we are giving him the added responsibility of a tech genius. And so you could just tell that if we are going to, and this is the phase in which we are right now, we are still collecting a lot of data, but if you are going to give this guy one responsibility, you should be able to take away enough responsibilities so that he can focus on that one and do it very well. And so one of the things that we decided to do, and this will be on how we are going to present all the data we collect and how it's going to augment people's lives and how we are going to integrate it into people's daily lives. And so this is a quote from one of my professors. Unfortunately, he's gone on to do other things, and his name is Stuart Gold. And so in class, he always said, you can't run away from information that is directly in front of you forever. And the reason why we are doing this is, usually when people build technologies, they like to put them in apps and ask people to download and do all of that. And you can't really guarantee usability, but if you always put the information directly in front of them, then there's nothing they can do. And so we decided to rent billboard spaces in town. They do a lot of adverts, and so you could have a big map displayed and just show the location of where each car is. I know in a lot of advanced cities, these things already exist. And then the other reason why we decided to use billboards is because it's actually very expensive to use, like Google Maps and all these services on devices, but there are not that many billboards in town, so we can pay for each billboard and forget about monthly subscriptions. And so there are also things like consumable API interfaces for DVLA. So DVLA is more or less the regulatory body in terms of road transportation and safety. And as I mentioned earlier, for example, we don't know how many buses are on the streets, and these buses are privately owned. We don't know the condition they are in. How do we guarantee safety and all of this? But by having the fact that we have structured data in the midst of all this chaos, you can attach items like unique IDs to every vehicle, which can easily be done. And then there are also other data that we are collecting from other AccraWAN projects. And so some of this data is it's still in conversation, but hopefully within weeks it will be approved. And trying to monitor how, the light goes off around town, because that's a big issue here. So that, for example, if you're a woman and you're working late and there's lights out in your neighborhood and your bus is on its way there, there are people who you can know ahead of time and ask people to meet you, so that, you can still be guaranteed safety and protection in your everyday life here. And also, we have crowdsourcing sites, so like yearly hackathons with all the data that we collect, so that the community can also contribute to that. And and the most important thing will be to collaborate with all these transport unions to come up with a redesign of the way these buses operate, because if there's somebody shouting and you can just mount a speaker that does those things for you, you take away one responsibility. If you have a simple to use interface where people know where they are going, and so as soon as they enter the bus, they don't need to be asked, that's something that can be done. And as I mentioned earlier, we can also figure out a way to redevelop how routes are accessed in the country, so that you don't have too many buses going to the same place, but at the expense of people going to other places. And so that's where we are at right now. And I'd like to say big thanks to these partners who have been giving me the money and the expertise to do this. So Invent Electronics, Global Code, the Things Network in New York, and TDFL. And special thanks to Dr. Fred. So those in this room, I wouldn't have to mention them, but they'll see their name on the presentation. And Dr. Dume, my math professor, and Abdul Hamid, my great friend who's been helping me a lot with this. Thank you all.